worksheet that we did the first problem of on Monday. And so now I've got just, a kind of concept question here on asking what is a register and what's the difference between serial and parallel data. So does anybody have an answer to that? Like what you think a register is and what the difference is between serial and parallel? All right, so what a register is usually made of flip-flops or latches. So it's a collection of flip-flops or latches. And you may or may not remember when they first taught you flip-flops, they introduced the concept of memory. And it's like it doesn't really seem like memory, so you may have forgotten that, but that's what it is. And so the collection of flip-flops or latches that store 1 bit of memory each. So that's what a register is. So it's basically a memory circuit. And you also have something called a shift register. Is a register in which you can shift the bits. So we talk about shifting the bits, we talk about moving the bits right or moving the bits left. And if you think about it, and you may not have thought about it before now, but when you have a binary number, like let's say I have this binary number 1101, that's my binary number. If I shift, the way you probably instinctively read this is you probably think, okay, this is the 1's place, the 2's place, the 4's place, and the 8's place. So you probably think of this as 8 plus 4 is 12 plus 1 is 13. And that is correct when this is the most significant bit, MSB, most significant bit. But not all computers operate with having the most significant bit on the left. Sometimes it's on the right. And so you're not going to have to worry about that a lot. I have to worry about it because the different professors who teach this class are used to different convention, and the way they write their homework will have it in a different way. But yours will always be consistent. And I think y'all had Dr. Trahan for first semester. Yeah, so it's always going to be consistent. And so yours are going to look like this, which means that when he writes a number, so if it has different places, he's going to call this bit 2, this bit 1, and this bit 0, because so he's always going to number them that way, because this is going to make this one the most significant bit and this one the least significant bit. And that's also going to be important when you do Verilog, when you assign something as a vectored signal, what's the most significant bit and what's the least significant bit. But if you think about taking this number and shifting the bits to the right, so this bit goes here, this bit goes here, this bit goes here, and this bit goes away, then I would have 0, 1, 1, 0. And now the number that I have is 6. So I went from 13 to 6. So I basically divided the number by 2. And if I shift things to the right, if I take the number 0, 1, 1, 1, which is 7, and I shift it to the right and I get 1, 1, 1, 0, then that's the number 8 plus 4 plus 2, 14. I multiply it by 2. So shifting is a way of multiplying and dividing by 2, and you'll use that a lot in when you take microprocessors. But that's kind of just an aside. I was talking about register and the difference between serial and parallel data. So serial means one at a time. Parallel means all at once. So when you transmit data serially, that means that you're giving the data, here's the first bit, here's the second bit, here's the third bit, here's the fourth bit, you're doing it just one at a time. You do it parallel, you send it 8 bits at once, all at the same time. Okay, so now we're going to do this one. Okay, so it says complete the timing diagram for this circuit, assuming all Q outputs begin in the low state. So one of the things you want to check for these is first check and see if the clock is actually the input into the clock port on the flip-flop, and it is. So we know that they're all going to be operating at the same time at the positive edge of the clock. So we've got that. And they're all starting at 0. So, and the input into and what kind of flip-flops are these? Yeah, they're D flip-flops. And the input into the first one is, I can't read that, but it's supposed to, it means, it's usually you'd say VCC, but that's going to be like the high voltage. And so the input into the first one is a high voltage, and high voltage means 1. So, I've got this one here. Okay, so high voltage means 1. And what does a D flip-flop do? Anyone want to take a guess? Well, is anyone going to tell me what a flip-flop does? Okay, so that's what a T flip-flop does. So a T flip-flop, it toggles if the input is 1. And so I said just a minute ago that a register was made up of flip-flops, each of which stored one value. And so what a flip-flop does is it kind of sort of stores a value. A D flip-flop does for sure. But it has an input, and from that input you get an output, but the output might depend on the previous value. So just before we get to this, I need to know if y'all really don't know, in which case I'll pull up some examples, or if y'all are just being quiet. Okay, so let me pull up, I'm going to pull up some different examples, not sequential yet, but of just a single flip-flop to make sure that you know how to do those. So, what was last semester, 2024? Fall. Let's see if I have any in here. Oh, I know I have some in 27 for me. Oh, yeah, actually, I had a really good SI session on this last semester that none of y'all were there. I remember exactly who was there, and it was not y'all. If I can find it. Let's see. Okay. All right, so I'm going to skip the SR latch because I don't think y'all are going to do this, but this will be just kind of your quick review of flip-flops. So what a D flip-flop does, so it starts with it, well, that's a D latch. Here's a D flip-flop. It's positive edge triggered. I can tell that because the clock doesn't have a bubble on it. This one is negative edge triggered. And so this is called a D flip-flop. This is a positive edge triggered. D flip-flop. And the way it works is, let me get all of these. So its output is called Q. And so it's it's called a characteristic table and not a truth table, but it really works the same way. So the Q star is the next value of Q. Q is the previous value of Q. So if the D input is 0, the next value of Q is also 0, regardless of the previous value of Q. And if the D input is 1, the next value of Q is 1, regardless of the previous value of Q. So D doesn't depend on the previous value. That makes it different from the other flip-flops. D only depends on the input. And we say that Q follows D. So D is the input. And so whatever the input is, that's what the output is. But it happens only on the positive edge of the clock, and we'll see an example of that. So when the clock turns from 0 to 1, the flip-flop looks at what the input is and then becomes whatever that input is. This next one is a positive edge triggered T flip-flop. And if T is 0, then Q is unchanged. So it does depend on what it was before. So when T is 0, the value of Q is whatever the value of Q was before. So if Q was 0, the next value of Q is 0. If Q was 1, the next value of Q is 1. So for a T flip-flop, when T is 0, it's unchanged. When t is 1, the value toggles. So if t is 1 and the previous value is 0, then the next value is 1. And if t is 1 and q is 1, then the next value is 0. So in words, what this says is if t is 0, q is unchanged. If t is 1, then q toggles. So that is a T flip-flop. The next one is a JK flip-flop. And the way a JK flip-flop works is if J and K are both 0, then Q is unchanged. So if J and K are both 0, then Q is unchanged. If J is 0 and K is 1, I always get this backwards if I don't look it up. And in the past, the first thing that came up on the internet had them backwards. Let's see. Oh, I would have gotten it wrong. Okay, glad I checked. Yep, okay. So if J is 0 and K is 1, that is a reset, which means that the next output is going to be 0, regardless of what the previous output was. If J is 1 and K is 0, then the next output is 1. And if they are both 1, then it toggles. And this is important for, the JK is not important for your homework, although you will have, I think you'll have a lab where you'll have to do one later on. But knowing how the T flip-flop works is important for your homework. So in words, what this says is if J and K, JK both 0, Q is unchanged. JK both 1, Q toggles. J equal to 0, K equals to 1, Q becomes 0, and J equals 1 and K equals 0, Q becomes 1. So let's do a quick example with one flip-flop. Right here. Okay, so we'll do this one that's a T flip-flop. So this is not sequential. This is just a single flip-flop, so not sequential, but you need to know how this works before you can do a sequential one. So this is a positive edge-triggered T flip-flop. So it's a positive edge-triggered T flip-flop, and assume that Q is initially 1. So positive edge-triggered, that means it only changes when the clock goes from 0 to 1. That's the only time you get a change. So I like to draw vertical lines wherever I have the positive edge so that I know where I'm going to have a change. So okay, so those are the only places it can change. And my Q starts at 1. So it starts at 1, it gets to the positive edge, and then it looks at the input at T. And what is the input at T right there at that first positive edge? 0. What does a T flip-flop do when T is 0? No change. So it's just going to stay at 1. Now at this next positive edge, what's the value of T? 1. And what does a T flip-flop do when it's 1? It toggles. It toggles. So it's going to go down to 0. Yeah, so it toggles. Yeah. Yeah. And so it was at 1, and since the T input was 1, that toggles, which makes it go to 0. So at the next positive edge, what's the value of T? Like where I've left off there. What's the value of T right there? 0. So what does the output do? No change. And then at the next positive edge, what's the value? 1. So what does it do? It toggles. Okay, now let's pretend for a moment that instead we had a negative edge triggered D flip-flop. Negative edge D. So it's not going to do anything at these vertical red lines. It is going to change at the negative edge. So I'll put in negative edge lines. Okay, and I'm going to assume that, again, that we're starting at 1. So start at 1, and nothing happens till I get to the first negative edge. And when I get to the first negative edge, I look at my input here, now I'm going to call it D. And what is D at that first negative edge? 0. And what does D do? It follows. And so if the input is 0, it's going to go down to 0. Okay, now what is the input here? Still 0, so it'll stay 0. Then at the next positive edge, negative edge, still 0. And the next negative edge, it's going to be 1, so it'll be back up to 1. Okay, so now going back to our sequential circuit. Here, our input into the first D flip-flop is a high voltage, which is 1. So what's going to happen at the first positive clock edge? It's going to go to 1. Now, this first flip-flop, is it ever, from here on out, ever not going to be 1?
No.
Yeah, it's always going to be 1 because it's got an input of 1. And so any time the clock changes, it'll look and it'll say, oh, my input's 1. So it's going to be 1 from here on out. But we assumed they all started in the low state. They all started at 0. So when I look at the second flip-flop here, this one is in the opposite order. I said Dr. Trahan is always going to label his in this order. The place I got this from has it in the opposite order. Okay, so when we look at this one, which is Q1, at the first, when it gets to the first clock edge, what is its input?
First clock edge.
Yeah, so we started with all of these being 0. Oh, sure. So we started with all of the inputs 0. And so the first flip-flop hasn't had a chance to change to 1 yet. So when we get to that first positive clock edge, the first flip-flop is busy changing. I'm going to become 1. But its output before was 0. So we've got a 0 sitting here at this flip-flop Q1. So what's its output going to be? It's still going to be 0. So it'll be 0 at least to the next clock edge. What about Q2 and Q3? They're also going to be 0. So just extend those. Okay, now I get to this clock edge. Now when Q1 looks at its input, what is its input now? 1. And so it will go up to 1. And then from here on out, is it ever going to not be 1? No. Okay, what about Q2?
Would it be 0 again?
It's going to be 0 again because its input is still 0, and Q3. And then what?
Then it would be Q1 for Q2.
Right.
And then it would stay 1.
Right. And then lastly, this one. So what we see here, is this an example of serial or parallel? Serial, because we're passing this 1 down one at a time, and it's happening one at a time. Okay, so now let's see, what time is it? 4:15. Okay. I'm going to be teaching till 5 today, or 4:45 or something like that. Just if you can stay. I don't know if I put an ending time anywhere, but all right. So that was this one. Okay, so now we're just looking at this as an analogy for a register. And so we want to see whether it's serial in, serial out, parallel in, or parallel out. So imagine this as a little conveyor belt, and I've got little things, falling on it. And in this first one, I have step 1, step 2, step 3, and step 4. So step 1 and step 2 are showing it entering, and step 4 is showing it out. So is this serial in or parallel in? In?
Serial.
It's serial in because I'm adding them in one at a time.
Yeah.
But what is it out?
Parallel.
Parallel out. Serial in and parallel
They both
out.
go out the same.
Because they both go out at the same time. Okay? How about this one?
This would be parallel in, serial out.
Right. And these pictures are on the worksheet on the they're in the SI resources on the website if you want to go back and look at them. The answers aren't there, but the pictures are there. Okay, what about this last one?
Serial in, serial out.
Serial in, serial out. Okay, so y'all got that now. Okay, so you will have to do this at some point, but I don't think it's on this homework. Let me take a look at this homework, so I want to make sure. It's not? Okay.
No, it's not.
Okay, I'll come back and do that. Let me look at this year's homework and make sure I do things like it. Homework 1. Okay, so we have,
You was able to understand it.
I think so. I'll clean it up.
It's just kind of.
It's just the fact that Q0 is the input into Q1, but you have to, but because it's negative edge triggered, you have to pick up like Q0 as your D.
we'll do something very similar to this. I'm not going to do this exact one. I'm going to change it up a little bit, but we'll do something similar that'll give you the idea.
Yeah, it confused me at first.
Yeah, it's got a lot of extra stuff to it. So I'm going to make it like this. Notice how the numbering starts with the 1 and then goes down to the 0.
I think the only thing that's really confusing me is to click through. If it was like with the negative edge
Yeah,
trigger that we just
it looks a
did,
little awkward.
yeah, then I would understand it.
Because like it has the second one first,
Mm-hmm.
or else first one doesn't.
So you can choose the first, last one.
You would do Q0 first and then you'll go to your Q1.
Yeah, because you don't have an input until you find out the aliens from Q0.
I think I know what this is. Give me 1 second.
I'm going to make them positive edge triggered. That shouldn't make much of a difference. So forget that little dot there. Let me get to the eraser. I will have yeah, that'll be good. Okay. So, well, I think this is one of the things that was confusing you all, so let me try. I'm gonna put a third one in here. Like this one 0, this one 1, this one 2. I'll have the output from this one going to this one. And I will have X being the input for both of these. Okay, so we have a clock. And I have my input, I called mine X.
It's kind of hard to see that.
That is ridiculously hard to see. All right, let me. Oops, 0, 1, 2. All right, so at the first, so this is positive edge triggered. So I'm only going to have a change at the positive edge of the clock. So when I get to the first positive edge of the clock, and I'm going to say Q1, I'm going to say they all originally start at 0. So they're all 0. And I'll look at Q2 first. When I get to the first positive edge of the clock, I can see its input is X, and X is 0. So what's it gonna do?
Stays.
Stay true.
It'll stay 0. It'll stay 0. Okay, Q1, what's its input? Q0. And what was Q0?
Also,
Also zero.
Also 0, so what's Q1 gonna do?
Following.
Yep. Q0, what's its input?
Feel
which is 0.
X, which is 0, so it'll stay 0. Okay, now I get to the next positive edge of the clock, and Q2 is going to look at X. What is X? 1, so it'll change to 1. Now, Q1 has as its input Q0. What was Q0?
1. Oh no, 0. It's 0.
Q0 is 0. So Q1 right here, its input is Q0, which is 0. Even though it's about to change, it hasn't changed yet. So it's still 0. Q0, its input is X. X is 1,
So it's 1.
so it changes to 1. Q2, what's it going to do at this next positive edge of the clock? Fall down to 0. What's Q1 going to do?
It's
Zero, so it's gonna go up to 1.
It'll
change to 1 because it's following
Q
Q0.
0.
it'll go up to 1. And what's Q0 going to do?
Also fall to 0.
Go down to 0.
I think I understand.
Q1 went up because of all.
Q1 went up because its input was Q0, and Q0, when it looked at it, Q0 was 1.
So, I'm not trying to say no answers for the homework and all of that, but so for 1 and 0, right? Are we starting at 0 or do we start what's closest to clock, which would be 1?
Wait, which one?
Do we start for 0 and 1 follows 0 since it's connected, or is it the opposite?
Okay, so the input, I'll answer general questions. And so the input for Q1 is Q0.
Okay.
And when it's deciding when to change, and notice this is a negative edge trigger clock, when it hits that, it's going to look at the value that it has currently, which means whatever the other one was before. So like they're not going to change, like you're not going to have Q0 change and Q1 change automatically based on Q0's change. So what I mean by that is just in general, let's say Q0 is 0. It's 0 right here. And then you get whatever edge of the clock it is that's going to make this change. And let's say this one is going to change to 1. That doesn't make any difference to this one because it's 0 was there when we got to the clock edge. And then this will become 0 and this one will become 1, and then next time around its input is going to be 1. I don't know if that was your question or not. I don't think it was.
It was.
Okay.
You answered part of it.
Okay, so we're saying that these are both starting at 0. So this
Right.
is 0, this is 1, this is 0, this is 1. And then they're both going to change or not change at, okay, it's a negative edge triggered thing, so I'm going to do positive edge. So this is not your homework, this is wrong. But if we get to the positive edge, Q0 would look at Z and say, okay, Z is 1, so I'm going to change to 1. Q1 is going to look at the input it had before, which was 0, and so it's going to change.
Oh, okay.
Would you say that objectively, for if the input of one D flip-flop is coming from another D flip-flop. That
It's
over
delayed by a
time
clock
is
cycle.
Delayed by a one clock
It's
cycle.
delayed by a clock cycle. That's exactly correct.
Okay.
Yeah. That was the whole point of my first problem, to show you how it rippled. It was like one clock cycle. So if you have D flip-flops, the signal is going to transfer one clock cycle at a time. So if I just had a bunch of D flip-flops in a row, and these were all D flip-flops, and I had a signal coming in, it was just that signal would just travel along those flip-flops just at a one at a time.
I got it.
Right.
Okay, does that help y'all do that problem?
Yeah, I got it.
All right, so let's look at the next problem on this year's homework. Okay, it's an up counter. Okay, he's done one like this many years. Let me get, what's that? Oh, you weren't talking to me. Okay.
Yeah, but like. Because if this, but like if that doesn't change, this would change if this was still down. But since this,
This this is okay. Basically, what I'm saying is, this is these are one way,
Yeah.
and this is
this
it's delayed.
changes
It
because it's
changes
on the
because
string.
it's
This
yeah.
is still one.
This is
because
still
this
one.
doesn't change. But because this one doesn't change. So if this was still zero, I'm saying that would go down. It wouldn't.
You know, I'm basing one off of the delay of 0.
Mm-hmm.
So if you already have, so basically like this, they start 0, right?
Yeah.
Then this one changes. This still stays 0. Then this one changes because of this.
Yeah.
And it stays because of this.
Yeah.
Then it goes down because of this.
Yeah.
See what I'm saying?
Okay, so let's just take a look at this one. Just real quick, I've got the answer up here so you can see how it worked. So we've got, these are D flip-flops, it's positive edge triggered, and when notice there's no change on Q0 until at the first clock cycle because it hasn't had a chance to get there yet. And so at the first positive edge, Z is 1, so Q1 becomes 1. Q0 doesn't do anything. At the next positive edge, Q1 is going to become 0, but Q0 is going to become 1 because that's what Q1 was before. And then at the next positive edge, Z is 0, so Q1 is unchanged. Q0 will become 0 because that's what Q1 was before.
Mm-hmm.
At the next positive edge, Q1 becomes 1 because that's what Z is, but Q0 remains 0 because that's what Q1 was. Yep.
Okay.
Okay, so now
Yeah.
let's take a look. This is not the same as the one y'all have, is it? Y'all have,
When the count is 0, explain what happens at each
Count is 0, 0, 1.
0, 0, 1 to 0, 1, 0. Okay, I think this one's different. Starts at 0, 0, 0, and yours starts at 0, 0, 1. Okay, so this one's slightly different. Okay. So, first of all, it says it's a 3-bit up counter. What does that mean?
A 3-bit up counter.
Uh-huh. It says it's a 3-bit up counter. Does yours also say that?
Yeah.
Uh-huh.
Yes,
Okay.
3-bit up counter.
Okay, so 3 bits means you've got 3 bits, and those correspond to Q, in this drawing, Q0, Q1, Q2, because that's the order that the book does it. And an up counter means it counts up. That means the next cycle you get 0, 0, 1, except, see how these are backwards?
Yeah.
1, 0, 0. You see, I'm used to, when I count up, I would have 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, and then you'd be back to 0, 0, 0. So these are just the numbers, binary numbers 0, 1, 2, 3, 4, 5, 6, 7, and then you go back to 0. But this is Q2, Q1, Q0, because the order of the bits has the most significant bit at the front, the way we read them. This has the most significant bit at the back. So the way this one would count would be 1, 0, 0, and then 0, 1, 0, and then 1, 1, 0, and then 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 1. So that's what it says. If it's an up counter, that's what it should do. That's the way it should work. We'll assume that they're not lying to us, that that's in fact what it is. Okay, so assume that Q2, Q1, Q0 equals 0, 0, 0 initially. For flip-flops 0 and 1, explain what happens and why at each of 3 points, Q0, the clock input to flip-flop 1, and Q1 at each of 3 time instances, the first active edge of the clock, the second active edge of the clock, and the third active edge of the clock. So let's just draw a timing diagram. So
Is Q2 the first one or the last one?
it's the last one.
Okay.
That's what I said, you got to be careful with
Yeah,
these
yeah.
because this one is kind of backwards. So Q0 is the first one. So what's going to happen at the first positive edge of the clock? What's Q0 going to become? Why? Be careful here. These are T flip-flops. You are correct, but why?
T is
It toggles, and what was it before?
0, 0.
Now, be honest. When y'all said 1, were you thinking that, or were you thinking, oh, this is like the ones we did before? It's a D flip-flop, and it becomes 1.
I was thinking about that too.
Okay.
Yesterday.
Okay. All right. So you had already. All right. So it was 0, so it toggles, so it becomes 1. Okay. What does Q1 do? Oh, look, it also has an input of 1. Is y'all's like this too?
Yeah.
Yes.
Okay. So what does Q1 do?
So it goes to 1.
It goes to 1.
If the toggles and it's already 1, would it already be 1? No, it starts at 0.
It says it
toggles
starts
to
at
They all
0.
start at 0,
Yeah. Okay. And then what does Q2 do? Oh, except,
Yeah, it's 'cause of
there's
the clock.
there's the clock. So we got to be careful with that. So is this the positive edge of the clock for Q1? So I'm looking at Q1. So Q1, its clock input is the not of the first flip-flop. So the first flip-flop, we want to look for when its not goes from 0 to 1. So what just happened on this one is Q0 went from 0 to 1. Did the not of Q0 go from 0 to 1?
No.
No. So its clock is 0. So if the clock is 0, it doesn't do anything. It's only going to do something when the clock changes from 0 to 1. Okay? So did the clock change from 0 to 1 for Q2?
No.
No. So it's also not going to change. Now I get to the next positive edge of the clock. So what does Q0 do? Sure, it'll toggle back, because its clock is the clock. And so its clock is the clock, and so it's going to, and its input is 1, so it'll toggle back to 0. Now, Q1, its clock is Q0 bar. Q0 just went
So
from 0 to
It
1.
would be 1. Because it's going from 0 to 1.
Yeah.
So Q
It's the
bar
opposite of
just
what
went
it is.
from 0 to 1. So that is a positive edge of the clock for this one. So it's a positive edge of the clock for this one. So what's it going to do?
Go to 1.
It'll go to 1. Okay, now what about for Q2?
It's still
What
well,
what did its input is the not of Q1. Q1 just went from 0 to 1. So what did the not of Q1 just do?
The not of Q1 just do?
Uh-huh.
Go 1 to 0.
1 to 0. Is that a positive edge of the clock? No.
it's not.
So
gonna stay 0.
it's going to stay 0. Okay, so now we get to the next positive edge of the clock. What happens to Q0?
It's going to come back to 1.
It'll toggle back to 1. What does Q1 do?
It's going to
toggle.
Are you
It's
sure?
gonna stay 0. It's going to stay 0 because
It's not 0 now, it's 1.
It's 1. Oh, I mean, it's going to go to 0 because
Oh.
it's the opposite of.
But what is it? How does a T flip-flop work?
If it's at 0, there's no change, so it,
Okay, so Q0 just went from 0 to 1.
Mhm.
That meant Q bar went from 1
1
to
to
0,
0.
which is not a positive edge of the clock, so there would be no change.
No, I said a not a positive.
Because Q0 went from 0 to 1,
Mhm.
but its input is not Q0, its input is the not of Q0.
Right.
So if Q0 went from 0 to 1, the not of Q0 went from 1 to 0, which is a negative edge.
Okay.
Okay, so
It will just stay 1.
it's just going to stay 1 with no change. Right. Okay, so, and did Q2 change? Let's see. Its clock is the not of Q1. Did its clock change? No.
So it's going to stay.
It's going to stay. So let's see what numbers these are. This gives us, I'm going to write them Q2, Q1, Q0. We started at 0, 0, 0. Then at this clock we got 0, 0, 1. Then at this clock we got 0, 1, 0.
What was it reflect? Just 0,
0,
Q,
1, 1.
and B.
I wrote these in the opposite order. Yeah.
Q2's at 0.
Q2's at 0 the whole time. And then I get 0, 1, 1. Does that look like an up counter?
Yes.
Yeah. And so when you're looking at yours, if it is a 3-bit up counter, which it is, you should be able to check your answer. Because if it's an up counter, your answer should reflect that. So let's see how he wrote this up when he assigned this last time. Let's see if this matches what we did, what we said. So I'm just going to let y'all read this rather than reading it out loud. But I find doing the toggle, the timing diagram helps, and then you can put it in there. So
Would he count that as part of our explanation?
I would think so.
Okay.
I would think having the timing diagram, but then some notes to go with it. But
Okay.
your notes wouldn't have to be as extensive as this.
Okay.
So I would, so let's look, does this match? At the first active edge of the clock, right here, changes from 0 to 1 because t equal 1 causes the output to toggle. Clock input to flip-flop 1 changes from 1 to 0 because the change at Q0. Okay, so it's saying you were supposed to, on this one, refer to, say what happened at the clock input. I don't think yours tells you that, does it?
It says when the counter, it says explain what happens at each clock input when the positive edge of the clock arrives, and then what happens at each output.
Okay, but you don't have to specifically say what the clock does, but
Yeah.
you'll need to like explain why.
Okay.
So like on this one, I probably would say the clock input to flip-flop 1 went from 1 to 0, and so that was not an active edge for that one. And then Q1 stays 0 because no positive edge at the clock input. And then it describes what happens on each one.
So we could still draw
A timing diagram.
I would think draw a timing diagram and then like write out to the side how the clock is affecting things.
Okay.
Because the clock that shows up here is only the clock for the first flip-flop.
So that means our start would be Q0, Q1 would be 0, and then Q2 would start at 1. Because it says when the count is 0, 0, 1. Or do they
Yes.
all
Changes
start
from
at-
0, 0, 1.
Now, another way to do it that I think would help, and we can do the same one like starting with a different value, is to realize that once I have Q0, it is the clock for Q1. So let's think about that. So I've got and I'll have them all start. I have Q0 start at 1 and Q1 start at 1 and Q2 start at 0. Okay, so Q0 has as its input 1 and the clock is its clock. So it's going to toggle at every positive edge of the clock. Now, Q1 has as its input the not of Q0. And so the clock for Q0 is the not, the clock for Q1 is the not of Q0. So it's going to have a positive edge whenever Q0 goes from 1 to 0.
Got it.
Okay.
Okay? So whenever Q0 goes from 1 to 0, that is a positive edge
And
for
even-
Q1.
But if it goes to, so say like, if it goes to 0 to 1, that means that Q1 doesn't change.
Right.
It wouldn't change because it doesn't stop.
It's not a positive
It's
edge.
not a positive. So
It's not a
gonna
positive
stay.
edge. Okay, so Q1 would have a positive edge whenever Q0 goes from 1 to 0. So that means it'll have a positive edge. Its input is 1, so whenever it has a positive edge, it'll toggle. So its toggle is going to look like this. And then the not of Q2 is the clock for, the not of Q1 is the clock for Q2. And so whenever it goes from 1 to 0, that'll be a positive clock edge for Q2. And so that's how that one would work. And we started with 110. We started with, I go the opposite way, 011. And then at the next clock edge, I got 101. Should have gotten 100. I messed up somewhere in there. Before you go, did you have any questions?
No, I'm good. Is there something to log this year?
Thank you, please. Oh, thank you so much. Yes, let me do that.
Wait, what does it start?
Hmm.
So,
So use that features like
If y'all could please get this QR code. If y'all could please all do this, it'd be great. I'll make sure I answer your questions. If you can't get it, you can come up and get it off my computer screen. It's probably easier to get it off the computer screen.
what is this for?
This is just for attendance. It's like important because I've been really bad about doing attendance and I get in trouble.
Thank you.
Thank you for reminding me.
Yeah.
If it's not working from that, it might work off my computer screen. Okay.
It was. It could be either your A9 or your
Yeah, either one. Email is easier usually.
It's your paper.
So what did you write those down? This was 001.
Yeah.
That's why they're kind of big.
Wait. 20.
Two zeros at the top.
Oh yeah, you have that.
And then,
It is it.
and then change the
It's
colors
just
down.
All right.
On my iPad.
And then let me just look because I'm going to have to go. But I think what we did will help you. Like it's the same idea with number 3. So number 3 is you're just following it until it comes back to where it was before. So it's not, you can't check your work the way we did on this one, knowing it's an up counter, but it's the same idea. Okay, so any questions before I?
Wait, so number 3, you can use a timing diagram to answer the question too?
I'm not the grader, so I can't. I would think a timing diagram would make it easy for the grader to explain. So I would draw the timing diagram and then in words kind of explain what it's showing.
Yeah, I was gonna say, it says, what is the sequence of the output values? How does it clock pulses?
Right, and so the sequence of clock values, you can read those off the timing diagram.
Yeah.
Do you see, like, the way I was just doing on this one, I was checking myself to make sure that I hadn't given y'all a bad example on this last one. I said we started with, because I know it's an up counter, we started with 011, and then the next time it changed, we got 100. That's right here. And then the next time it changed, we got, well, you don't want to do just because it changes. You want to do it at every clock cycle. You just read the values off. But I usually, most years I don't do it that way. Most years, like with one like that, I make a chart, and you know that. But I think the timing diagram, I like the timing diagram better, I think.
Yeah.
It's better than a
Makes it lot
chart.
easier. It's kind of hard to explain.
Yeah.
It's like, well, I kind of have a hard understanding of what it means by the clock's input and output.
The clock's input and
It
output.
says explain what happens at each clock input when that positive or when the positive edge of the clock arrives, and then
So each clock input, that means on the flip-flop itself, each flip-flop has the clock input that's determining when it advances. And so it's saying when the clock switches, what happens to the input right here? In other words, what did this do?
Okay.
Remember how we were determining whether or not we had a positive edge of the clock based on this? That's what it's asking.
Okay.
What is this assumption?
Yeah.
Assumptions? That's it.
No, it's not going to be the same. He does things that are very similar but not the same. And so you can look at the solutions from a previous year to see how to write it up. It was fall 2024. Looks like last year they didn't ask me about that, or last semester they didn't ask about that homework.
Still doing math into these it's still going on.
Okay, so you're still trying to figure out how to answer it?
Yeah, because
Okay. I'll give you an example based on the one that we did.
Okay.
Okay.
It's not making sense.
So,
to me.
where are we? Does anyone see? Okay, all right.
Oh, I see what he means by number 3.
So you're on this particular example. So I would say at the first positive edge of the clock, I apparently can't say that because if I try to type, there we go. Flip-flop 0 has a positive edge. So it toggles from, in our example, it toggles from 0 to 1. The clock input of flip-flop 1 is the not of the output of flip-flop 0. Flip-flop 0 went from 0 to 1, so its complement went from 1 to 0, which is not a positive edge for flip-flop 1. Flip-flop 2's clock is the not of flip-flop 1, which did not change. So it also does not have a positive edge.
Okay, yeah, that makes sense.
Okay?
Yeah. And do we have to do that for every single positive edge?
I think only for 3. Right?
For 0, 1, and 2.
Yeah, 0, it'll be 0, 1, and 2.
So,
because you had said at the first positive edge. And so I didn't know we had to do that for every single time it gets an edge.
yeah, I think so, but I think that would be 3 times.
Okay.
Let's see. Let me see. Consider when the count changes from 001 to 010. Oh, no, you don't. You just have to do it once. So, yeah. Right?
Mm-hmm.
Oh, yeah, so you just have to do it once.
Okay.
Yeah, you just have to, so just like I did, I just did this, I explained what happened at the clock input for each of these, for this particular change, you would do it for another change.
Okay. And I'm assuming that has, that it says then what happens at each output. So that's just.
It's all tied in there, it's
Okay.
all together, I mean, you can do it.
Yeah.
Yeah.
Okay, that makes sense.
All right, so I have to stop.